All right, yesterday we went and talked about probability. We talked about the addition rule though. So our key word for that yesterday was or. And anytime we saw that word or, it was set up the same way. It was 1 plus the other minus the third equals, and our denominators in every single one of them, every single one of them stayed the same. So this is what we did yesterday. What we're going to look at today now is our multiplication rule. So this has its own keyword. Its own keyword is going to be and. So you'll see and if you see and, that tells me I'm going to go ahead and I'm going to multiply. Now, however many fractions you need will determine on what the question is asking. But let's say it was only asking for 2. What you need to do is you will multiply the top with the top to get your answer and the bottom with your bottom to get the answer. So you will do multiplication straight across when you see this keyword and. Okay? This is where it's going to get a little confusing. You have to determine, is my denominator changing or not? Is that bottom total, right? When we look at a probability, we're looking at total on the bottom. Well, what we're going to look for is things like replaced or without replacement, puts back, does not put back, all of those questions, and that's going to tell me, does my denominator change or stay the same? So there's some key phrases and everything you're going to look at that we're going to talk about here in a little bit. From there, again, multiply straight across, and then your last step is to do that division piece. Okay, so let's go ahead and look at this. Mr. Meyer calls you to his office, and of course, you're expecting to be in trouble. However, he just wants to congratulate you just for being you. He offers you 2 prizes out of his prize bowl. In the bowl, there are 6 $5 Chipotle cards, 4 $5 Dairy Queen cards, 13 Snickers, and 27 Milky Way. What is the probability that you choose a Chipotle gift card and a Dairy Queen gift card? So lots of words happening, but in the question, it says, what's the probability that you choose a Chipotle gift card and a Dairy Queen gift card? So that is telling me and, meaning I'm going to multiply. I need to figure out how many fraction bars I need. So how many times am I going to dig into this bowl to get a gift? Well, that's going to be twice. I'm going in twice, and I'm going to multiply. Once I figure that out, I can now go back and I can look for replaced, puts back, does not put back, all of those different key phrases that is going to help me determine, once I find my total, will my total change or not? So in this situation, it doesn't say anywhere in here that when you pick it up, you put it back. So assume that they don't put back. So we're going to assume once you pick it up, you keep it. Okay, assume that we don't put it back. Once you pick it up, you keep it. So the first thing I want is the probability of a Chipotle card, Chipotle gift card. The second thing I want is the probability of a Dairy Queen gift card. Okay, and we're going to assume that once I pick up that Chipotle gift card, I do not put it back in. So piece by piece, probability of getting a Chipotle gift card. Well, total, let's figure that out. I know I have 6 and 4, and then 13 and 27. So I have 50 total items in this prize bowl. Chipotle gift cards, there's 6 of them I can pick from. So now assume that I picked up a Chipotle gift card and I put it in my back pocket. When I reach into that prize bowl, there's only 49 options left for me to choose from because I took one out already. And now we want a Dairy Queen gift card. Well, I didn't pick up a Dairy Queen gift card. I picked up a Chipotle gift card. So I still have 4 of those left in that bowl. So I'm going to multiply top with top. 6 times 4, I'm going to get 24. Bottom with bottom, 50 times 49, 2,450. We're going to go ahead and we're going to write out or divide that out. So I'm going to get 0.009. That third number is going to tell that second one what to do. So it's going to be 0.01. All right, number 2, the numbers for the state lottery are about to be drawn. There are 6 numbers that will be drawn out of a bowl, each time being replaced. What is the probability that the first 3 will be odd, the 4th will be prime, and the last 2 will be even? Okay, So a bunch of different things here. But in the actual question, what is the probability the first three are odd, the fourth will be prime, and the last two will be even? Okay, so Ann tells me I'm going to multiply. So now I need to figure out how many times I'm reaching into this bowl. Okay, well, it tells me there's 6 numbers that need to be drawn out. So I go 1, 2, 3, 4, 5, 6. And I'm multiplying all of these together. Okay, assume that when we're talking about the state lottery, the numbers are going to be any single digit number. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 that I'm drawing from. Now it says each time being replaced. So once I pick it up, I'm going to put it back in for the next drawing. So that's going to be some good information for us to keep in mind. Let's figure out what we're looking for. Probably the first 3 are odd, so I need the probability of an odd. First 3 of them are odd, so probability of odd, probability of an odd. The fourth is going to be prime, probability of a prime. And the last 2 will be even, so probability of an even, probability of an even. Okay, let's put our total on the bottom. So I have 1 through 9, which means I have 10 total. Okay, the first thing I'm looking for is odd numbers. Well, in 0 through 9, I have 5 odd numbers, 1, 3, 5, 7, and 9, so I have 5. I picked up an odd number, but I put it back down so that I could pick it again. So there are still 5 odd numbers out of the 10 total. I picked that one up, I put it back in again. Still 10 total, still 5 odd. Picked up an odd, put it back in. Still 10 total, but now prime. Remember your prime numbers, 2, 3, 5, 7, 11. So of these prime numbers, how many are in this list? There's 4 of them. I picked it up, I put it back in, still 10 total. Now even, 0 is considered an even number, so we have 5. I picked it up, I put it back down, still 10 in there, even, still 5. So we're going to multiply all of the tops together. So 5 times 5 times 5 times 4 times 5 times 5. I'm going to get 12,500. Denominator, 10 times 10 times 10 times 10 times 10, all those 10s. I'm going to get 1,000,000. So now when I divide that, I'm going to end up with 0.012. Look at that third number. It's less than 5, so it's going to tell me that one stays the same, so 0.01. All right, a couple left. I know this is a hard topic, so hang with me. Okay. You pick a card from a regular deck of cards, and then you put it back in the deck. Then you draw a second card. What's the probability the first card you drew is a spade and the second card was a face card? Okay, so I'm going to look at the question, probability that the first card you drew is a spade and second card is a face card. So I know that I'm multiplying, and I'm going to pick 2 of these cards out. That's what it's saying, the first card and the second card. So I only need 2 fractions for this one. It says you put it back. That's going to be really important for us to keep in mind. Let's figure out what we're looking for. The first card I drew was a spade, so I want the probability of a spade. The second card I drew was a face card, so probability of a face card. All right, let's find that first one, spade. Well, total deck of cards, I know, 52. Okay, spades, there's 13 of those. Now, I picked that card up, but I put it back. Remember that really important key term, put it back? So I still have 52 available to me to pick from. And of that, 12 are still face cards. So now we can multiply 13 times 12, 156, over 52 times 52, 2,704. Divide that out, I get 0.057. That 7's going to tell that 5. We got to head up 1. Okay, let's look at number 4. You and your friends are going on a road trip, so you pack a cooler for everyone. You fill the cooler with 12 Gatorades, 10 Cokes, and 13 waters. If you reach in and pull out 3 beverages, what's the probability that you pick 2 Cokes and 1 water? Okay, in that question, I see and. Okay, so I know I'm multiplying. I have to figure out how many times I'm multiplying though. So in this situation, it says you reach in and you pull out 3 beverages. So I'm gonna pull out 1, 2, 3 beverages. It says the first 2 you pick are Coke. So probability of a Coke. Probability of a Coke. And then your third one is a water. So probability of a water. Now, it does not say anything about putting it back. So again, we're gonna assume we don't put back then. Anytime it doesn't say anything, assume that they don't put it back. All right, let's figure out our total. I have 12 Gatorades, 10 Cokes, and 13 waters. So when I look at that, I have 35 total items in that cooler. Of those 35, I need to figure out how many are Cokes. Well, there are 10 of them. So I reached in, I grabbed a Coke, I took it out. Now, in that cooler, there's only 34 items to choose from left. And since I took a Coke out, there's only 9 Cokes left. So I reached in, I grabbed a second item, and it was another Coke. So now I have 2 Cokes that I took out of there. So total, there's only 33 items left. And of those, I only took out 2 Cokes, so I still have all 13 waters left. So we're gonna do 10 times 9 times 13, 1,170. 35 times 34 times 33, 39,270. So I'm gonna end up with 0.029. That 9 is gonna tell that 2, gotta go up 1. All right, let's look at this last one. 3 cards are drawn from a standard deck of cards without replacement. Find the probability of drawing a heart, another heart, and a spade. Okay, so and again tells me multiplying. And I need to figure out how many fractions I'm multiplying. It tells me I'm drawing 3 cards, so we're gonna do 3 of them. 1, 2, 3. The first card I want is a heart. Probability of getting a heart. Second one is another heart. It's probability of another heart. Third one is a spade. So now I need the probability of a spade. I think I drew a club. That's not what I wanted. But you know the idea. You get it. Okay, so let's go ahead and look at this. I am doing this without replacement, meaning I pick it up and I put it in my back pocket. I am not putting it back in that deck. So probability of a heart first. Well, there's 52 total options to pick from. Of those, 13 are hearts. So I picked up a heart, I put it in my back pocket. So now there's only 51 cards left to pick from, and there's only 12 hearts to pick from. So I picked up a heart. I now have 2 hearts in my back pocket. There's only 50 total cards left, but spades, I haven't taken any of those yet, so I still have 13 of those left. So 13 times 12 times 13, 28. 52 times 51 times 50, 132,600. Divide it out, you get 0.015. That 5 tells that 1, we gotta go up. So 0.02. Good luck on the assignment.